家乡的波霜，窗前的月光，都照亮心底某个地方。有人用思念两段足石行，流淌过1000年，恋恋难忘。你有绿树红墙，替我遮风霜，也有草长白云白，吹到长城长。天水煮小巷，早上老火汤，在家3分时光，坐在门前慢慢唱。人间烟火山河浩荡，清风过大江，水路弯弯连海浪，两岸千里的花香。你爱的人啊，记得你最好模样，你是大宝的忠贞，是心之所向。时代滔滔向前，温柔而勇往，留不我梦中的你，花开遍山岗，蹒跚着成长，离开又回望。你是年也是香，是冬眠的歌当。人间烟火山河浩荡，大雪落夕阳，午夜钟声是响，一粒团圆的泪光。你爱的人啊，永远放你在心上，就算已白发苍苍，也别泪光。人间烟火山河浩荡，你任我去闯，多少个还会东望，最远最近是家乡。我爱的你啊，泪落千年的时候，挽着小小马跟我靠近你的光。要用尽啊，用一生才懂寻常。我与你啊，遇到时擦肩相望，这一刻忘了奔忙，也忘了沧桑。爱的人还在身旁，落叶又回到枝头上。哇 Hello, good morning, good afternoon, good evening. 早上好，中午好，晚上好。おはよう、こんにちは、こんばんは。这是编程的实况编程。Today we are going over fast and slow pointer. Moving on from the what was that before? 2 pointers. Okay, so a fast and slow pointer approach is also known as a hare and tortoise algorithm. It's a pointer algorithm that uses 2 pointers and one move faster, one move slower. We usually use that because we want to detect whether the list that we are looking at has a cycle. So if it's a cycle, then the fast pointer will eventually meet the slower pointer. And then after we finding the cycle, we can also determine the middle point of the cycle. And how we do that is Logan just thought it was a Genova stream. I'm not streaming Genova today. Today we're doing some programming. So let's say that we have like a circles like this, right? And we have 2 pointers, so pointer 1 and pointer 2. So if we make the pointer 2, assuming this is a cycle, right? If we make pointer 2 to move 2 steps ahead and pointer 1 to move 1 step ahead, right? So the next cycle, this will be here, and this will be here, and this will be here, and next cycle will be like this. Yeah, next cycle will be like this. And then next one will be like this. And then next one. And then next one. So now pointer A and pointer B will meet. And pointer 1 and 2. So that's how you determine there's a cycle. And it's not a cycle. Like for example, if like this, we can have a pointer to move to ahead, and keep moving to ahead. If there is a no, if there's a no here, there's nothing else to do, then we determine that this is not a cycle. The reason why we do this is this is a faster This is a faster time complexity. So that's the basic of 2 pointers. Let's move on to the next. Actually, next. So linked list cycle. Given the head of singly linked list, write a function determine if the linked list has a cycle in it or not. So we have a head and it's a linked list. So usually in a linked list you have my traverse from head next, your node next. The number is these are very important. This the constraints are how big the list is and how many nodes within the list. So let's start. Solution heads. Okay, so right now it provides a constructor for us. The constructor it only contains 2 functions. So if this.val returns the current val of the current nodes, and this.next returns the next nodes, the address of next node. So we want to find whether this list is a cycle. So again, we start with pointer 1 is equal to head right now, and pointer 2 is also equal to head. And while does it tell me what the values are? How do we know it's the same? While pointer 1, actually no. So we want to start the list first, otherwise this condition will not. While pointer 2 is not no. Pointer 2 doorbell is not no. So what I want to do is let's make this faster pointer. So pointer 2 is equal to pointer 2 dot next and then pointer 1 is equal to pointer 1 dot next. If pointer 1 is equal to pointer 2, remember these two are pointing to the, I believe they are pointing to the address of the node. So if the address is the same, then we found this, then this is a if the address is the same, then this is a cycle. Otherwise we continue this this loop here. So let's run this. Cannot read property of no reading value. Okay. So pointer 2 eventually hit no. So there's no value here. So just pointer 2 if is equal to no. And run this. I started. And we submit this. Oh, cannot read property on next. So if we enter 1, so the input is 1. There's only one node. So which means next will become no. And next will also become no. So the power is like this next dot next. I think this is a edge case. So what we want to do here is what I want to do is here we go to next on pointer 1 and pointer 2. If pointer 1 is equal to no, or pointer 2 is equal to no, then we break out this loop, which will return false. Otherwise we keep doing pointer 2 dot next. Submit. Accepted. Also, hello 吴子星星 Cassie Vanilla. Yeah. Next. Given to pointers blah blah blah. This is kinda easy. This is the first one. So what we are doing is we have a fast and slow pointers. We keep moving the fast pointer until the fast pointer either hits a no, or it went back to the, or it enters a cycle. So if we enter a cycle, we keep moving and keep moving. Eventually, if the fast and slow meets, that means we detect a cycle. So this is next. Also, they did it this way. If fast is not no and fast next is not no, then he took this. I guess it's easier. So instead of writing this condition here, we can do and P2 dot next is not null. Then we can remove this bar. Dot next. So if we submit this, still accept. Next. Even the head of singly linked list, write a method that returns the middle node of the linked list. If the total number of nodes in the linked list is even, return the second middle node. So in this case, middle is 3. So it goes from 1, 3, 3, 5. Next is no, so we set here. So 1, 2, 3, and then 1, 2, 3. After reset, it moves again. So middle is 3. And in this case, if we add additional number, because now this is the event, the number of nodes is event. So fast will be 3, and then fast at 5, fast and no. And then you went back here. So 1, 2, 3, 1, 2, 3. Slow is here, and then fast will be at 3. Slow is at 4. And then fast 5, slow 5. So it's 5. In this case, the middle node is 3 and 4. Because the list is even. And they want the second node, which is 4. Oh, okay. So if they count, fast will be 3 and then fast will be 5. Fast will be a node. If we set node to 1, actually, you know what? That's 1, 3, 5. Next is no. So slow, the middle will be here. And fast will be 1, 3, 5, and then no. At this point, this will be here. So the next one will be 4. Okay. So we don't need to loop this. So by the time we reach the end, the slow pointer will be our middle. And when we hit the end, we just determine whether the current number that we hit is even number or not. Okay. So again, we do a P1 is equal to heads and P2 is equal to heads. And in addition, we need to make a counter. So I'm gonna start the counter at 0. And it'll be the same thing while P2 is not null. But P2 dot next is not null. How was that? How was my Valentine's Day? Well, it's same as every single person. So what we want to do is p2.next. p2 is equal to p2.next. And if p2 is null, if p2 is null right now, then we found a then this is not even. This is all numbers, so we can just return break. And then p1 is equal to p1.next. So if p2 is null, then we just break it out. And so this will just return p1.value. Val will be the middle. That will be the middle value. And then we got p2 equal to p2.next again. If this one is null, then we know it's an even number. So we don't even need counters here. If we know this is an even number, then we want to return. Then p1 is equal to p1.next, because we want the second of the middle. We want the second. We want the second value of the middle node, because it's all numbers. So the middle node is 2 nodes, and we want the second one. So if we detected this is an even linked list, then we return. Then we go to the next one for p1, and then in the end we just return p1.val. So run this. Cannot read property on undefined radian length. Huh? Radian length? I don't have a length in my code. I'm a hacker? Yeah, I'm a hacker. So you better watch out. Assignment to constant value. Huh? I don't have length here. Cannot read property undefined. P1 is head, P2 is head. While P2 is non-null and P2.next is non-null. P2 equal to P2.next, P1 equal to P1.next. If P2 is null, then we break out this while loop and we return P1.value. If P2 and then P2.next. If P2 is null, then we increment P1 and then we return this. Joe screw crosses. You normally this is not real coding. It's not real coding. They are testing you. Basically they're testing you the objective programming. And they want to test you on linked list, and because and they want to test you on linked list without providing you the length of the list, as well as the exact index and stuff. So they have to make it into a class. So when they make it into a class, so the head will becomes a becomes an object in JavaScript, so you can do the traverse the linked list. So this is purely for testing your algorithms. You don't really do this kind of stuff in real life. So we need to figure out why this is not working. Now. Assignment to constant value. Oh my god. I don't know what's going on here. Oh, wait. Oh! I forgot the break here. Okay. Run. Still broke. Haven't used like listed size school. That's they just want to test your coding stuff. Nah. I remember doing linked list when I was learning C++. Cannot read property or undefined. Reading links, but I don't have links in my code. P1 is not defined. That's exactly. Cannot read property. Okay, so this is where this part is where it's complaining. So is it this? On returning P1.val. Oh, they just want me to return P1? Is that what you want? Damn. Okay, so output is 4, but the expected is 3. Let's see. P2 is equal to P2.next, which is here. And P2 is not null. So we go P2.P2.next. And it's still not null. We continue the loop. And P2.next is 4. Still not null. Right? And then P2 here. This is still not null, so we keep going. And then next, oh, that's why. So, and then at this point, P1 will be at 4. Okay, so in that case, we do P1 here. Run. Accept it. Submit. Output is 5. Expected is 4. So first P1, P2 is here, P1. And then P2 here, P1 is here. And then P2 here. And then P2 here, P1 will be here. And then P2 is here. And then P2 again. And then P1 before. Wait, P1 before. So 1, 2. They will be here. Next will be here. Oh. Okay. Okay. Accepted. I feel like I can shorten this somehow. The reason why it wasn't walking before is the first P2 that we found, we break it out. The P1 is already at middle. So in the second we increment P1 again, and we found a node on P2. Then we don't increment P1, because if this one is the middle, then this P1 in increment would be the second of it would be the second of the middle two nodes. If it's an even number. Okay, next. Okay, this is a lot simpler than mine. If fast is not no, fast. Slow is equals slow next. Fast is doing fast next. Oh. You don't even need to compare. Eventually, so what I'm doing here is basically what I'm doing already here. So we can do a P2 to next. Since we just need to return P1. P1 equal to P1 dot next. So we submit this. Cannot read property of next. Of no. P2 dot next and P2 dot next. Run. Huh? Isn't it the same? Bus is not no and O and so we want, because this is to next, so we want the next one to be for sure no. Okay. 1. Next. Start of linked list cycle. Given the head of singly linked list that contains a cycle, write a function to find the starting node of the cycle. Okay, example, the head is here. And the starting cycle is here. So we want to find this number value here. And the head can also be the start, but it does not have to be start. It could be the start of cycle could be in the middle of the linked list. Okay. Let's see. If we do a fast and slow pointer, fast will be here, fast will be here, fast will be here. If 1 then me is the middle. So fast here, slow here, fast here, slow here. Fast here, slow here. Fast here, slow here. So the middle will be fine. How do we find a star? And then fast 3, slow 6. Fast 5, slow 3. Fast 3, slow 4. Fast 5, slow 5. They meet again in the middle. Notifications. Do you wanna do you like coding? But this one meet in the middle again. You do it for a living, okay? Hacker. Hey, you are studying in economy. Oh, good luck. And in that case then, if you are going to... If you're going to, if you're going to job market, then this stream might help you. Because that's what the big companies test you when you apply for a job. Prime sub didn't notify. You said it notified you, right? Wait, hold on. Did it not notify you? Okay, how do I find the start? Companies test you on shit you never use. That's exactly. Like all these things that we are doing right now. They will test you when you apply for the job. But the actual job that you are doing does not require any of these at all. In the second case, fast here, slow here. Fast 3, slow 2, fast 5, slow 3. Fast 4, slow 4. They actually meet here. In the third case, fast 3, slow 2, fast 5, slow 3. Fast 1, slow 4. Fast 3, slow 5. Fast 5, slow 6. Fast 1, slow 1. They actually meet again. But why is the first one will be fast 3, slow 2, fast 5, slow 3. Fast 3, slow 4. Fast 5, slow 5.
what's the mid? If I increase the fast, so fast 4, slow 6, fast 3, slow 1, slow 3. If they meet again, then it's the start. Okay, let's apply the assumption to the second one. So fast 3, slow 2, fast 5, slow 3, fast 4, slow 4. They meet, and then we do fast 4, slow 5, fast 4, slow 6, fast 4, slow 4. They meet again. So 4 is the starting. If we do this, fast 3, slow 2, fast 5, slow 3, fast 1, slow 4, fast 3, slow 5, fast 5, slow 6, fast 1, slow 1. Okay, and then after they meet here, we do fast. So fast 4, slow 2, fast 1, slow 3, fast 4, 3, wait, 4, 2, 1, 3, 4. This doesn't work. You don't understand the concept of fast, slow, linkless. The concept is if to detect whether there is a cycle or not, and you can after detecting the cycle, you can find the middle. So we detect there is a cycle, and we know what the middle is. With those two informations, how do we find the starting? If we keep a counter, the counter doesn't work because we don't know what the beginning. We don't know where it starts, so the beginning tar we cannot discard. We know the head of list, but we don't know what the start of cycle is. We can find where the middle cycle is. So after finding the middle cycle, yeah, so in this case, we want to return 3. In this case, we return 4, and in this case, we return 1, because this is where the cycle starts. And I make a new one. And a layer. Oh, this layer. No. I want to add a new one. New page. New join. Screen size. Yes. Can I copy? Can I copy this? Damn. I don't think using hash map is actually no. Hash map. If we put each of these nodes into a hash map, and the slope pointer will be putting into hash map. After we detect the middle, we continue the slope pointer, right? And slope pointer will be putting the nodes into hash map until the nodes is already exist. Then we found the starting hand. I think we can do a hash map here. So let's P1 equal to head and P2 equal to head, and hash equal to new hash map. While P1 is not equal to, we know this has a cycle, so we can do this. While P1 is not equal to P2, I should know what. So what if the values are? What if the values are the same? I guess in this case we don't care what the value. We just push the. The node. We save the node into hash. Wait, that case we don't even need P2. I believe there's a function called map here. New map. Get set. So hash equal to new map. Well, hash doesn't have E1. Right, so we store hash dot stat P1, and then we do P1 dot next. And then we return P1. In this case, we don't even need. I feel like this is wrong. But if we find a loop, so if we have P1, so 1, 2, 3, 4, 5, 6. So the hash map right now has 1 to 6, right? And eventually the 6 will return back to 3. So, and then return by the 3, then we check the hash map. If the 3 already exists in the hash map, right, then we know this is the starting loop. So I feel this is it. It's not even using the pointer, so I feel it's wrong. I'll put this 1, x 3. Oh yeah. P1 equal to B on the next. I forgot. So this output is 3, that's correct. Oh, so this is easy then. We don't even need to know. We don't even need 2 pointers, because we know there's a loop exists. So we just keep pushing the node until we find a duplicate. So that's basically solution accepted. Yeah. And how we find a starting node is just we find a node that we already visit. We find the first node that we already visit. Then that first node is the starting node of the cycle. But then this thing is using 2 pointers. If we know the length of cycle, we can find the start cycle through the following steps. Okay, so we basically cheated. I cheated. The question is asking me to solve this with 2 pointers, but we did it with 1 pointer. So initialize both pointers at the start. We can find the length of cycle using the approach discussed in the linked list. 難しいや。少しね。We can find the length of linked list using the approach discussed in linked list cycle. Let's assume that the length cycle is k. Move the pointer ahead by k nodes. Now keep incrementing pointer 1 and pointer 2 until they both meet. As pointer 2 is k node ahead of pointer 1, which means pointer 2 must have completed 1 loop in the cycle when both pointers meet. Their meeting point will be the start of the cycle. And pointer 2, pointer 1. Move pointer 2 4 nodes ahead. And then keep putting 1. And pointer 2 would be here. But where do they get the 4 from? We cannot use the algorithm to find the length of the cycle, then follow this above method to find the start of cycle. Yeah, they never did. But they say you can find the length yourself. Linked list cycle. It's only finding whether it's a cycle or not. So they have a slow and fast. Well, fast, known as fast is okay. This is the standard. If slow is equal to fast, then we found the cycle. So linked list. Is equal to this dot calculate cycle length, and then putting in slow. The current is slow, cycle length is 0. while true, current equal to current on next length plus if current is equal to slow. Calculate the length of the cycle by moving through it. So current is slow. Slow is in the middle. Current on next cycle plus 1. If eventually current will hit slow, and then we return the length here. Oh, that's how you find the cycle. This overly complicated, I feel. What is this website? It's called Design Guru. Design Guru coding interview. No, they actually not for memory optimization. I think my solution is way optimized than their version, but I think their version is taking into account for the future stuff because they wanted to solve this with using a linked list. And then after you find how long, the length of the cycle. This finds the length of the cycle, right? After return, then you find a star. But it starts by assessing the head and then cycle length. So whether 1 is happening to its head. While cycle length is greater than 0, pointer 2 equal to pointer 2 the next. And then cycle minus 1. While pointer 1 is not pointer 2, pointer 1 is equal to pointer 1 the next. Pointer 2 equal to pointer 2 the next. Oh, this is overly complicated. So, like, take this for example, 1, 2, 3, 4, 5, 6. Okay, let me explain. So what they are trying to do, let's say 6 points back to 3. Oh, this is big. And 2. So 6. This is big. Can you stop making the pain bigger? No size control. Let's say 6. Too big. How do I make this thing small? Oh, this. Let's say the cycle is here, right? So what they were doing is that they have P1 and then P2. So they will go with the original. So P2 moves 2 ahead, and P1 moves 1 ahead. So eventually, when P1 and P2 meets, in this case it's 5. When they meet at 5, right? They take P1 and then calculate the length of this loop. Right? I think they calculate. Yeah, so they remember this syntax here, and then they calculate by moving P1 one by one until they hit this number again, and then they have a counter here. So this counter is 4. Like after they found the counter for that, which means they found how the length of this cycle. And then they take this length of the cycle. They do this again. They apply this thing into the linked list again. No, this time they move P2. They increment P2 to the length of the counter. So P2 will start here now. Right? P2 will start here. And then they will continue to do the same thing. So P2 move by 1. P1 move by 1. And then P2 will move by 2. P1 move by 1. Eventually they will meet here. Right? I believe that's what they're doing. Wait, don't get it. If pointer 1 and pointer 2 are moving 1 node ahead, they will never meet. So what they're saying was, they found the loop, and then you increment pointer 2 by the length of the loop. And then you increment 1 by 1 for each. So P2 will be here, P1 will be here. And then P2 will be here, and P1 will be here. Or increment by 1, so increment by 4, so P2 starts here. And then P2 plus 1 will be here. So they meet at 3. Okay, this is the solution. Okay, look at it. This is the solution. They will meet at some point here. This is the solution that they provided. And this okay, now check out this. I'm gonna make a new drawing. Oops. And so this is the whole algorithm of finding that starting point. Okay, let me show you mine. Mine is 1, 2, 3, 4, 5, 6, and 6 return here. So we just have 1 pointer, P1. We keep moving P1 until we find a node that's already exists in the loop. Then this is the final node. That's it. That's our algorithm versus what they want you to do algorithm. Don't you think mine is way simpler? Right? We don't even need 2 pointers. We can do it with 1 pointer. That's all n space, yeah. That's true. But this one, the speed is also over 1. Time complexity is also over O of n. In the other case, they loop this twice, so with 2n. Well, technically, it's still O of n, but this is gonna be faster than what they had. If I get this out, then they probably don't know. Possibly. But since this is a testing linked list, I'm gonna write it in linked list. So it's a new map with the P2 again. Well, P2 is not null. And P2 dot next is not null. Everybody's taught here for people knowing hash map. If you can apply hash map to something, you apply hash map to something. Usually, there's a joke about in programming where people romanticize applying hash map to the problem. So P2 is equal to P2.next next. And P1 is equal to P1.next. So if P1 is equal to P2, then we found the starting node. I mean, we found the middle of the cycle. So after we find that, our new function now is find the length of the cycle. Cycle length. This will taking the current P1 pointer but you know what? In their solution, their space complexity can also be. Actually, no, they're not saving this current. So if P1 is equal to P2, then we want to calculate the length. Cycle is equal to 0. Then cycle is equal to cycle length. And then we placing P1 in here. So let's set the target is the current value. And then we have a counter is equal to 0. Alright, so we keep doing while true. We can do while true here because if this is detected, then we know this is a cycle. So we can do while true here. While true, then current, in this case current is, actually, you know what? Target is equal to current. Yeah, current is equal to current dot next. And then count plus plus. And if target is equal to current, then we return the count, so we know the cycle is. if we find that, we break it out. But after we break out, we know the cycle length. Right, so let's console log right now, just to make sure we're doing right. Run this. Console log is 4, so the cycle is 4 here, and that which is correct. So after we find the cycle, now we need to find the starting point. Then we return starting point. Start equal to add and cycle. Right, so start function start, we have head and cycle. So in this case, we let P2 equal to heads and P1 equal to head and P2 equal to head. While cycle is greater than 0, P2 is equal to P2.next, and then we decrement cycle. And then while P1 is not equal to P2, we do P2.next, and then P2 equal to P2.next, and P1 is equal to P1.next. And when they meet, that's the starting point, so we just return the starting point. Alright, so run this, correct. Submit this, correct. So that's what they wanted us to do, instead of the other one. What is this? This is programming. So compared to the previous, I still think my solution is way better in real life. So this breaks into 3 parts, right? The first part is finding the cycle. So we do P2 increment by 2, P1 increment by 1, and when P2 and P1 meet, we found the middle of the cycle. So when they meet, we found the middle. That P1 will be the middle of the cycle. So that's the first part. And then the second part is after we find the middle of the cycle, we set the target to the middle of the cycle, and then we increment P1 by 1, not P1. We increment that node 1 by 1 until we meet that node again. And then we have a counter just to count how many nodes was incremented 1 by 1. So this finds the how the length. This finds the length of the cycle, right? That's the second part. And then the third part is to calculate the start of the cycle. We calculate that by starting from the beginning again, and then we increment the second pointer to the length of the cycle, and then we start incrementing them 1 by 1. And this is basically so basically the length of entire linked list minus the minus the cycle length is equal to the non-cycle part. It's equal to the non-cycle part. So we increment first. We put the second pointer to the length of the cycle, and then we start incrementing both of them. So the amount that increments is equal to exactly the length of the non-cycle. So after we traverse through the length of non-cycles, then we start at the beginning of the cycle. So we return the beginning of the cycle. That's how we get that's how we detect cycle and then return the beginning of the cycle from here. I'm finding the star. But we don't know, like, we don't know the length of this, and we don't know where the star is. Right, so first thing you want to do is you find the cycle, and then you traverse within the cycle, and then you find the length of the cycle, and then you begin the 2 pointers. One of them will be have the. So, okay, so after you find the length of the cycle, right? Since we still don't know the full length of the linked list because we are not saving any data. Like in the first iteration that I had, we use a hash map, and if we use hash map to do that, then we will know the length of the linked list. But if we do that, then the space complexity will be a big O of n. Right? So, and if we don't use that, right? So now we don't know the we don't know the whole length of the linked list, but we do know the length of the cycle linked list. So the whole linked list minus the cycle linked list would be equal to the non-cycle linked list, right? So that's why you begin the second one. You begin the second pointer from the cycle, right? From the length of the cycle, and then you increment both of them, and they will meet because they will eventually meet because we are only traversing the length of non-list cycle. So the first one will eventually enter the cycle, and the second one because we started the second one will traverse exactly the length of the non-cycle. So after it traverses the length of non-cycle, it will exactly end at the start. So when both of them meet, then we know that where the start is. Yeah, so we need to find the cycle and we need to find the cycle star. So this breaks down into 3 parts. Crazy stuff. Oh, the algorithm is not slower. So it is O of n and then O of n k, but O of okay. So remember in big O notation, O of n, they only care about if it's exponential, right? So the first one we did, the time complexity is O of n, and the second one we did is O of n plus n minus k, where k is the starting the length of the cycle, where the k is length of the cycle, right? So then this one becomes 2n plus, actually not 2n minus k, right? So it becomes a big of 2n minus k. But since we only care about the exponential complexity, so this converts to big of n. So technically, yes, technically the first one will be a faster, but in the grand scheme of things, they only consider both of them are equal. So in this case, in the eyes of algorithms, coding challenges, they are considered equal in time complexity. Am I drawing that with mouse? Of course. If I draw it with my hand, if I draw it with a pen and paper, then it will look much better. And I know it looks weird now. Also, for the first one, the space complexity is also of n. And are we saving anything here? And the space complexity of the second one is O of 1. Yeah, but I know it's technically faster. In time complexity, it's technically faster, yes. But in coding interview, they don't care about constant value. So there's a 2 here, but they don't care about constant value. They only care about if it's exponential. Right. So in time complexity, both of them are the same, and space complexity, the second one is faster. The second one is smaller. Have you learned React? Yes, I know React. React is good because a lot of company. I mean, in terms of in terms of finding job. Okay, in terms of finding job. No, hold on. In terms of how good the framework is, React is no longer the number one. So there's always something new that comes out that has all the like latest stuff, and it makes it simpler. It makes you simpler to code, and like you can put in whatever package easily that's pre-made already for you. Right? In terms of how good the framework is, React is not the number one. That I can tell you. However, if you are looking for a job, that's the most important. Money is the most important part. Okay, React is currently the number one framework for the front end. If you are using JavaScript, right? It's number one because it exists for a long time. It exists for a long time, and a lot of company already adapted to it. So like in the real world, it's not like when there's something new comes out, every company is gonna switch to that new thing, even though it's better, but switching over takes resources. You have to recode your code base, right? So the companies don't want to do that, so they will stick to whatever they have picked in the first place, and most people picked React. So that's why when you're out for looking for a job, they are more likely, way more likely looking for React than they are looking for the shiny new framework that just put down. So yes, if you're thinking about that, yes, if you want money, then learn React. If you want, like, I don't know, challenge yourself, then learn the new things. Because eventually, if you're chasing for the new things, even if you chase those new things, unless you keep adapting to the new things, then you would always have to relearn this process. You can inject React into PHP, yes, you can do that. You don't need to. Okay, so here's the thing. You don't need to put React into PHP. So you can use PHP as your backend code, and the React part will just be standalone in the front end. In the front end as a pure JavaScript framework in the front end. So and then you don't have to mix them together. So that's why they have APIs. So you have the front end calling the backend via a application programming interface to the PHP backend, and then the PHP backend will do all the backend stuff like reading database, calculating, doing all the calculations, and then send the data back to your front end, and then your front end will display it. So you don't have to mix them together. You can have them separate, and you just have them communicate each other using an API. That's what most companies do. Unless you're COBOL programmers, you know what? You know all the new graduates or new programmers that come out, none of them know COBOL, right? But a lot of legacy infrastructures are which they're either too expensive to replace, or they're not replaceable because they cannot stop that thing and then just have everything move over, and then stop that thing and then like develop new things and then move over stuff. COBOL is actually still in demand because all those legacy stuff that they cannot move over. So it's all about supply and demand, because all the new people that join the job markets don't know COBOL. So whoever that knows that, to whatever company that was stuck in that infrastructure, they are most valuable resources that they can get. However, like it's not forever, but like eventually it will get replaced, because eventually those older programmers is gonna all retire, and then they have no choice but to migrate to a newer standard. Yeah, you can actually demand more money if the company is stuck in a legacy system, and you are the only few people that knows that legacy system. Then you can demand, and the legacy system is very crucial to that company. Then you can demand like high prices. They can be replaced in the future, yes. And if you're using that old system, your pool of jobs that you can find is very narrow, and they're shrinking. They're for sure shrinking and narrow. But if you do find one, then you can demand a lot. Yeah, eventually you will become obsolete. Like, eventually, yes. But it's very, very hard to like. You don't understand how many legacy codes are there that like the company just don't like, because it does very simple things, or it does very low level stuff that the company don't want to spend so much money to replace them, or they're already in the process of doing that, but they cannot find talents to maintain their system. So in that case, you can demand a lot of things. Yeah. So it's you know, in the I mean, in the fantasy land, everyone would want to be in the highest standard, the latest standard that there is. But the real world, there's a lot of factors involved. So basically you can apply the same thing as in the React thing. React is still evolving, but there are also new stuff that came out. Like React themselves is somewhat bounded by their initial design. Yeah, like take for example, do you think banks are going? Do you think banks are going to obsolete? No, right? The banks are always gonna exist. But did you know that most banks codes are run on legacy Java or C++? Because it's more at that time when they first had them, it's considered more secure because it's strongly typed. Even though now the newer languages, for example JavaScript, they have TypeScript stuff, but at the time when the bank was rolling out their systems, these things don't exist at that time, and the banks, they don't want to replace their giant legacy systems, so they still need people to maintain those old codes, right? So banks are not going obsolete. So you would think that okay, if I still learning legacy Java, am I going to go obsolete? No, because you will be still good for like the pool of job for that is shrinking, but so is the pool of available talents for that job. It's too risky to replace and also too expensive to replace. And also security stuff, you know, all that shit. Anyways, we've been talking about job for a lot. I'm gonna stop the stream here. I don't know. Do you guys want? Should I play it? Macedon? Alright, because this kind of string is burning. It's burning. It's burning my brain cell. You want to do that themselves? No. I'm gonna go rest and then I will think about it. Yeah, especially my throat. Cause I talked in high pitch because it sounds cuter. But it's more damaging to the throat. Am I in the job market? Actually, I was in the job market, and then I got laid off. So now I'm just doing whatever. Anyways, see you guys later. Bye bye.
唱歌关于你梦中的理想国，空间时间交织，连成线融在身边，不知又不觉，眼看不见，难道这真的没有存在过来过？蓝云眼泪生和像电一朵昙花盛开在。